Thank you for attending. Thank you for the organizers for having me. First, a few words before I get started. My name's Simon. If you know me, you might know me from my work on the Dart ecosystem. I maintain and I started originally the Drift package. I also maintain the SQLite package, these bindings using Dart.ffi, and a few smaller packages like the tar implementation used by pub, for instance. In my main job, I'm a software engineer working on PowerSync, but apart from a few name drops, PowerSync is not what this talk is about, because this talk is going to be about SQLite and Drift. And specifically, I want to kind of show you a bunch of cool features of SQLite, first of all, that I think are the reason that make SQLite a really great fit for all kinds of persistence needs in your app. So it's kind of ridiculous to sort of hype up SQLite because it's already insanely popular. But yeah, in just my opinion, I think it's kind of crazy how good SQLite is as a client-side database. And I would kind of like to show you why. So first, if you've never heard about SQLite before, kind of the like main part of what makes SQLite is that it's a database engine, right? Like it supports SQL statements, like your select, update, insert, delete, the kind of statements you learned about. It kind of has a syntax similar to Postgres. It's more like a subset of that. But the really cool thing about SQLite is that it's part of your app, right? Like it's a C library that you can link in your app, and with Flutter you can just bundle it along with your app on all native platforms. And then instead of talking to a server like with Postgres, you can just invoke a C function using Dart.ffi. And obviously we have these kind of cool packages that help you with that. And that is kind of like a really cool thing because you get the full power of SQL, but you don't get the like performance downsides of having to talk to a server. And obviously if the user's offline, it's really nice that everything is just a simple file. So, just kind of going quickly through some of the SQLite benefits. First of all, it's like really, really popular. So it's installed by default on iOS, Android, macOS, and Windows, and technically also Linux. I guess nothing is really installed by default on Linux because you could be like running on a embedded device or something like that, and you don't have nothing on there. But on all Linux devices that can run Flutter apps, it's almost guaranteed that you're going to find a copy of SQLite on there. So it's probably the most widely used database system in existence. And the authors of SQLite, I guess we kind of have to take their word for it, it's estimated that there are about 1 trillion active SQLite databases in use. So it's not only extremely popular, it's also extremely well tested. The reason for that is that I think they wanted to use at some point SQLite in like aviation software in planes, and the bar to be able to do that is just extremely high. So the tests aren't public, but they have about 600 lines of tests for every line of actual source code that makes up the library, right? So they have a really, really high test coverage. And interestingly, they don't just focus on correctness, like obviously they do, but in addition to that, they test specifically for I/O errors and out-of-memory conditions. Right? Like these kind of things that never happen on a developer machine, but happen all the time out in the world on like weird low-end devices. SQLite has you covered for that. And they also test for recovery in case anything goes wrong, like ensure that it's really hard to corrupt the SQLite database if you do the right things and know what you're doing. So a key feature of SQLite is that it has a static schema. And there's like some pros and cons for this, and people have different opinions on this. But for me personally, I really enjoy being able to declare my tables and all the columns beforehand, and then have the database engine enforce that I'm not doing anything stupid at runtime. So like all relational databases, I declare a bunch of tables, and for each table, I will declare the columns that are part of that table, and that includes defining their types. I can also define whether a column is able to store null or if it's a non-nullable column. I can also do things like declare foreign keys, which essentially mean that a row is supposed to reference another row, and then if that reference gets broken, the database will reject the update that caused the break, which is kind of convenient as a way to express invariance in your database schema. Same note on that is you can essentially do something custom, right? Like you could say, okay, this column is an integer, but it can only store, I don't know, even integers for whatever reason. And then you can just put that in the column definition, and you can expect that to just work. So this has a bunch of benefits, I would say. So a perhaps obvious one is that you can, this allows the database engine to be a lot more efficient, first of all. Because if you look at something like Hive, for instance, or like a collection-based database, and then let's say we want a query like, I don't know, I have some integer column, and I want to sum up all these integers across the entire table across different rows, then if you have a static schema, the database engine can essentially just look at the offset where that integer is going to be stored for each row and fairly easily sum them up. But if it's like a JSON-based schema, you would have to essentially read all the data, decode it, extract the one integer you care about, sum it up, and ignore the rest, right? So this leads to more efficient queries. And I think the biggest benefit is that this leads to type safety. So I want to give you a quote by someone who agrees on me on that. And again, you're free to have your own opinions on that, but this is what I agree with. And he says, okay, like this is a criticism of like dynamic schemas, like collection-based database like MongoDB, or I don't know, something like Hive in the client. And he says, well, all this flexibility that you could get from dynamic schemas, it's had in the same way that PHP and JavaScript need weak typing steps you right in the face. If a field should store an int, it should store nothing else. Not a string, not a picture of a horse, but an integer. It's nice to know that I have my database doing type checking for me. And this is the kind of vibes that I agree with. It's just kind of nice, right? Like we have static typing in Dart and in all of Flutter apps, we are able to benefit from it. So it makes sense that we should have the same guarantee in our database. This is why I enjoy working with static schemas, and I hope you will enjoy working with that too. So, just some quick SQLite features. We have transactions like we would expect from our database, which means that we can update an arbitrary number of rows in a atomic transaction, and we can ensure that nothing outside of the transaction, even if the app is like force closed during the middle of it, there's never going to be a state where I can see half of that transaction afterwards. Another cool thing we have is indexes and triggers. So I don't know, like as a cool example of triggers, I don't know, maybe we want to have like a table that stores which writes have been done locally while the user was offline, so that when the user comes back online, we can, I don't know, sync them to a backend server or something like that. Here it's just kind of convenient that I can declare that as a trigger and says, okay, if there is an update on a table, I will insert into this other table, right? If I didn't have that, I would have to do it in the domain layer of my application. I would have to make sure that my repositories are implementing this kind of thing. And it's just kind of convenient to be able to do it in a single place, and that ensures that the database is going to take care of that for me. Being a SQLite database, being a SQL database, it has like full SQL support, so you can use aggregate and window functions. This is an example of a window function where, I don't know, maybe we want to select some to-do items, and we want to know out of all the to-do items, if I were to sort them by how many words they have, at which index would a particular to-do item be, right? And if I had to do that in Dart, the only efficient way to do that would be to load all to-do items, sort them, and then compute the index. And in SQL, I can just kind of write it down that way, and if I have the right indexes, then that's going to be a very efficient query, right? So for these kinds of analytical workloads, even if you have them on a client, it's kind of convenient to use something like SQLite. And finally, you don't have to read through this crazy query, but just to give like an upper bound of what's possible using SQL, maybe you have your to-do items in a kind of folder structure, and then each folder is a row that references the parent folder. And by using something called recursive common table expressions, you can essentially iterate through a parent folder and then start selecting like your child folders. And again, if you didn't have this, you would have to start loading the parent folder first, then see what kind of children there are, load those, and then sort of do the recursion in Dart. And it's just kind of convenient that you can do this in SQLite, and it's going to be like a single call. So it will be a lot more efficient than something you might have in Dart. All right. Which platforms does SQLite support? The answer is all of them. So because it is a C library, it has excellent native support, obviously. That's where it started out as. So you can use the SQLite package that I wrote for Dart using, internally it uses Dart FFI, so it has like a very low overhead binding to SQLite. And again, yes, because it is a C library, it runs on all the native platforms that Flutter runs on. So all your mobile devices and also the popular desktop operating systems have excellent SQLite support. The situation on the web is a bit tricky, but the cool answer is you don't really have to care about that. So the main challenge is, because SQLite has started out as a C library, it kind of expects to be able to do synchronous I/O, right? Like in C, if you read and write from a file, then by default that blocks the thread doing the write. And on the web, we only really have asynchronous APIs, right? Like IndexedDB is asynchronous, and the other file system APIs are kind of asynchronous too. So bridging that gap is a bit of a challenge, but the good news for you is that is a challenge for library authors such as me or other people doing their work for different languages. And you as a user get something that mostly just works at this point. And yeah, at work, we have some cool challenges. We have some cool projects cooperating with like JavaScript library authors having the same challenges. And we will probably have something really cool that will make this extremely reliable very soon. Okay, one kind of cool feature I still want to show off is that SQLite can be used in a multi-threaded application. Now, most Flutter apps are kind of, you probably have your UI in a single isolate, so it's kind of single-threaded. But even if you have that, you might have different widgets depending on database queries, and then it can be very convenient to run those queries on different isolates in parallel, so that your UI is just more reactive and snappy. And SQLite really helps with that, because the way it works is that you can configure it to use two files, where you have like the main database file showing all the older rows, and then when a writer wants to insert new rows or update rows, instead of writing directly to the database file, it keeps like an append-only log of its changes. And then when it's done in a transaction, it inserts like a marker into this file. And if I start reading from the database, the reading thread is going to find like the last marker at the time the transaction was started. And then it will consider the content of the main database file and this div of the append log. And this architecture allows a single concurrent writer and an arbitrary amount of readers that can operate on the database in parallel. So that's something that you don't really get using systems like Hive or shared preferences or either. And it's kind of a cool thing, because that can really speed up your queries. Finally, something I want to mention is, because SQLite is so intensely popular, there's also an existing ecosystem of plugins that exists around it, right? Like just how we have a growing Dart ecosystem, but different packages, we kind of have a similar thing for SQLite independently. So SQLite out of the box is already a pretty capable database engine, but there are always some features where you might say, okay, I kind of want SQLite to do this, and it doesn't do it out of the box. And then, probably there is something that can do that for you within the SQLite kind of ecosystem. So for instance, if you need to encrypt your local storage for whatever reasons, then there are different options for that. So there's the SQL Cypher project, which is a commercial offering, but they have a free version available. And there's the open source SQLite multiple ciphers package, which is probably what I would recommend if you start using encryption with SQLite today. So that just works. If you need to use full text search, like just a string-based search in like human written language, there's a built-in support for that using the FTS, which stands for full text search extension in SQLite. That mostly supports Latin languages, but if you need, for instance, some Asian languages, then the SQL messaging app, they have an open source extension that you can plug into that, and then you get support for that as well. If you want to use like local embeddings and vector search, there's an extension for that, which is quite popular, and SQLite is also working on integrating that into the main databases, and so they're also working on that, so that will get even better soon. And then finally, I also want to shout out some options for data synchronization. So especially if you say coming from Firebase Cloud Storage or something like that, and you want your SQLite database to get synchronized, if a user has different devices, or even if different users are collaborating on the database, there are different options for that. So on pub.dev as an open source package, there's SQLite CRDT, which essentially provides some helpers to you if you want, like essentially it transforms the SQLite database into data structures that can be synced across devices. And my employer PowerSync is also a more complete solution that is entirely based on SQLite, in the client at least. So that's kind of a cool thing, because if you're using SQLite, then you can adopt all of these and they just kind of plug into SQLite. Like it's not like, I don't know, maybe if I want to use PowerSync and FDS5, then those would be incompatible. No, because they are all based on SQLite, you can just use them together, right? So pretty much any of these two, or even any combination of those, they should be compatible with each other. All right, so now I've spent like 15 minutes trying to hype up SQLite. Now we come to the more fun part of this talk, right? Like now I kind of want to show you what I've specifically been doing with SQLite and the packages that I've been writing for Flutter. So why should we even use Swift? Like, if SQLite is so nice, why can't we just use it directly from Dart? Right? Like, what's the missing piece that I'm trying to fill here? So, as I mentioned, SQLite has a static schema, and I generally think that's a really good thing. And also in Dart, we have not a static schema, but we have a static type system, right? Like, and I also think that's a really good thing. So it's kind of unfortunate then that we have static typing in Dart and we have static typing in the database, but our queries, as I will show, are kind of ugly, right? Like this is just standard SQL. We start off by running an insert statement, and that just does standard SQL insert. And the way it works is to prevent like SQL injection attacks, I will use a prepared statement parameter, and then I will bind the value using a separate Dart value. And this kind of works, right? Like this would work. But let's say I have a typo and maybe I forgot about the name column, or I misspelled the name column, or instead of passing a string as a parameter, I pass a picture of a horse or something like that. It would just be kind of unfortunate. But because I'm just passing a list here, there's no type safety, right? Like if I pass, I don't know, number 42 instead of the string Simon there's not like the Dart compiler can't see, hey, you're doing something stupid here. The database query is going to fail at runtime, right? And similarly, if I want to read, again, I just do the select star from users. And then I know that each row is going to have an ID and a name column because I declared them in my schema. And I also know that my IDs are going to store integers because I declared it that way, and the database is going to enforce it. Same way for names, which I know are going to store strings. So it's kind of unfortunate then that I have to write these casts in Dart to use the correct types, right? Because I know the correct types, the database knows the correct types. It's just a SQLite package that unfortunately doesn't know what's going on. So, before I show you anything else about Drift, I want to show you how these two queries would look like if you were to adopt Drift. Right, and basically looks like this. And you can see it has overall the same structure. And if you, just based on vibes, I hope that I managed to get these APIs in a way that you can kind of feel the SQL underneath of it, right? Like there's like high-level APIs here, and there's like names instead of strings. But you can, reading this, it's kind of obvious, I hope, that the first thing is going to do an insert statement, and these lines here, these three, they're going to read all rows from a table and extract some information from that. So how does this help then? Well, first of all, instead of passing a string and then passing Simon as a parameter, I now get to pass it as a named parameter in Dart. And Drift generates this insert constructor for me. And essentially what that does, it has all columns that are required for all columns that are required for new rows in the database. They're going to be marked as required parameters on this companion. And that means that if I forgot about this name column or if I misspelled the parameter, then obviously because it's generated code, I would get a compile time error from Dart, right? Like it would just get an error, hey, you forgot about this column. At the same time, if I forgot about or if I misspelled the users table, then I would get a compile time error because the getter doesn't exist, right? Like it's just this one users getter here. And I get a similar level of type safety for selects because I'm explicitly passing the table I want to select from. And then, instead of having to use map access here and then casting, I can just spell out the column I'm interested in as a getter. And because that getter is typed, I get the correct type back and I don't have to cast. So yeah, this I hope captures what Drift is trying to do, or what's like the main goal of Drift. We don't hide the SQL from you, but it should be obvious looking at these methods what SQL they would generate internally. The thing that we do save you from is having to manually specify all these types like casting and forgetting parameters, because a consequence of this also, if you update your schema, then you will just get compile time errors if you forgot to update any queries. Whereas if you were using raw SQL queries in your app, you wouldn't get that, and you would kind of have to have a pretty complete test suite to detect that easily. So, to summarize what Drift actually is, Drift is a database toolkit, right? That's the word that I would describe, maybe like database library or database toolkit. So things that it gives you is it gives you compile time errors for things that are guaranteed to fail at runtime, which I think as Dart developers is hopefully something that we appreciate, because that's one of the nice things about Dart and statically typed languages in general, that we can find more errors at compile time. Some other cool things that I'm going to show you in a minute is it gives you auto-updating queries. So if you have any kind of select query, it doesn't matter how complicated it is, you can just have Drift run it again and again if any of the affected tables change. And that's going to be really cool for state management. I'll also give you an example for that. Another cool thing about Drift is it lets you compose transactions much more easily. It helps you with migrations, and it has some built-in helpers to make running SQLite on all platforms. But like I mentioned, that especially for the web, it's a bit tricky. So it has some helpers for that I'm going to show you. What Drift is not is an ORM, right? Like I wouldn't say that Drift is an ORM because in my mind, ORMs are kind of trying to hide the SQL away from you, right? Like you have this high-level object-based structure and you have your relationship managed as different objects. And this is not how it works with Drift, right? With Drift, the idea is still that you have your SQL underneath and you can kind of feel the SQL that Drift will generate underneath. We just make it safer and more efficient for you to compose SQL statements. And the kind of unofficial goal that I've been trying to lay out for Drift is, if you use SQLite in a Dart-based app, and I hope I was able to convince you so far that SQLite can be a pretty excellent option, then I think Drift should be a very good fit, right? Like I think it would be really weird if there was like a use case where you say, okay, SQLite, I'm using SQLite, but Drift doesn't really fit what I need, right? Like the utilities that it provides should cover everything that you want if you're dealing with SQLite. So I will just briefly show you how you can define tables and queries in Drift, but I think if you're interested, obviously the documentation and the examples that we have in the repository is a better fit for that. So I'll just kind of go over this very quickly. But basically the way it works is just as if you were to define a table in SQLite as like a create table statement, Drift also needs to know about all your tables. The reason for that is that Drift generates code that references the structure of your tables. And to be able to use type safety in your app, first of all, we kind of have to define the types. So in this case, in the example that I've used throughout this presentation so far, we had a users table and it has an ID column, which is an integer. And specifically, I can tell SQLite that instead of me providing this integer for every new row, it should just increment it locally. And I have a name column. And kind of the difference between Drift and SQLite is that in Drift, we follow the convention from Dart to make columns non-nullable by default. And in SQLite, I would have to add an annotation for that. But in Drift, it's kind of fine. And then after I've defined my tables, I can define another class, put a Drift database annotation on it, tell Drift about the tables I intend to use, and then I run build, run a build. Like with all other code generators, that's the single entry point command that I have to use. And then afterwards, so this is a method I could manually write. Drift generates this superclass for me, and I can reference the generated users table, and it contains all the information about columns and information about how I would map a row from the database into a row that would be supported by Drift. Another thing that I can do in Drift, so maybe if you prefer writing SQL directly, but you still want the benefits of type safety and Dart, then something that Drift can do is we provide this concept of a Drift file, which is just essentially a text file containing SQL statements. And you can put basically any kinds of SQL statements in there, right? So for instance, if you have a table you want to use with Drift, or if you're coming, say, from a different architecture where you've used SQLite before, you can just copy paste your create table statements, put them all in that file, and then tell, you use the same Drift database annotation, except that instead of specifying the tables that you want to use using Dart classes, you just tell Drift to include a SQL-based file. And then the code that Drift will generate for this versus the code that Drift will generate for the Dart definition is actually the same, right? Pretty much byte by byte is going to be the same. So the API that you use to actually query, write your queries in Dart is going to be the exact same thing. So I don't really, have a preference to give to you whether you should use the Dart API or the SQL-based API. Maybe something you consider is that if you're using, I don't know, like LLMs to help you, then they might not know all about Drift APIs, or maybe at this point they do, but they will certainly know about SQL. So that can also be something to consider if you want to use agentic app development. It's kind of a nice tool that you can just put everything in SQL, have Drift validate that for you, and kind of guide either you or your agents towards writing valid SQL. So it only makes sense that in addition to writing your create table statements in Drift, in SQL, you can also write additional statements in SQL. So in this case, we just have a select star from users, the same query that we had before, but we can give it a name by just writing the name and a column before of it. And then if I build one again, for each method that is defined here, Drift will define a method on the generated database class, and I can just call it to run the method. So yeah, that's kind of a cool thing, because while Drift Dart APIs support most of what SQLite can do, there are some things that are just really hard to express in Dart. Right? So for instance, I showed you the example before of using recursive common table expressions to kind of traverse through a directory of folders. And it's just kind of tricky to express that in Dart, because we kind of have to define a query that then compiles to SQL and then gets run and then gets sent back, and it's just kind of complicated. But if you just literally specify it in SQL, then Drift is going to figure out the types and generate like a wrapper for you in Dart. A downside of defining all queries in SQL is that maybe you have a bunch of queries that are kind of conceptually very similar, but still have distinct in some ways, right? So for instance, maybe I don't want to select everything from users or the entire users table, but rather I want to attach a filter to it. And then maybe some widget is going to search by name and another widget is going to search by IDs. So the query overall is still going to be very similar, but I need some kind of custom filter. And Drift has support for embedding Dart-generated expressions and other things into SQL queries. So if you use this like $sign-based syntax, then that is kind of a variable that can be instantiated to custom Dart code. So here, for instance, I'm referencing an optional filter. And then if I run the build runner again, I get this method that has a name parameter. And then the inputs to that parameter, this is a callback function, and the inputs to that are all tables that are in scope. In this case, it's only the users table. And then I can compose a custom expression, or in this case, just a fairly standard expression. Like I can just use the entirety of Drift's Dart API to embed Dart expressions in my SQL queries, which I think is hopefully quite a nice feature if you're mixing, or if you're starting off with mainly using SQL, but want some customizations based on Dart. Well, I've also mentioned that Drift can turn every SQL query that you can select from into an auto-updating stream. So we've seen in all our previous slides here that in the end I'm calling .get, and I can literally replace this .get with .watch, as shown in this example here. And the nice thing then is that this gives me, instead of .get returning a future, this is going to return a stream. And I can use this stream in pretty much like any other stream. So I could literally use it in a direct stream builder, or in any other abstraction like a stream provider, like an async notifier from Riverpod, whatever kind of state management solutions you want to have. You can probably plug a stream into that. And yeah, that's kind of a nice abstraction then. Because you can react to the stream contents, obviously, and you can have your UI update dynamically based on what's currently in the database. And then if anything writes to the users table, all the relevant queries that are currently live in some parts of your UI, they're going to get rebuilt with the updated contents. So I think that's like a really nice way to compose state and applications by just putting everything into the database and then updating relevant queries as they go. So finally, actually not finally, but another cool thing about Drift is that they make it very easy to use transactions. So in SQL, you can use begin and commit statements to manage transactions, and we have some kind of virtual support for nested transactions using SafePoint statements. But it's just kind of tricky to keep track of all these statements and to kind of keep track of which connection is currently operating in a transaction context and which isn't. So in Drift, it's kind of very easy. You just call the transaction method on the database, and it's going to give you a callback. And then as long as that callback runs, it's going to run in a transaction. So Drift ensures that you can't have two transactions that happen at the same time, because again, there can only be a single writer appending to this writer headlock. And another cool thing, it uses the zone APIs in Dart async. Like, just show of hands, have you heard about the zone APIs before? Okay, I see a few hands. So basically, zone is an abstraction concept that exists in Dart async, right? Like the core library that provides streams and futures. And essentially, if you have any kind of asynchronous flow in Dart, it's always going to run in a zone. And by default, it runs in the root zone, but we can fork that off and essentially have this entire block run in a custom zone. And what Drift is able to do is it can attach the fact that we're running in a transaction to the current zone. And what that then means is, if I call, like you will notice here that there's no transaction callback to this, no transaction argument to this callback. It's just like a zero argument callback. And if I use any other function that uses the database, then implicitly that function is going to run in a transaction, right? So I don't have to carry around a transaction object that I have to pass to all my database methods. It's just implicitly, if there's any transaction block in the await scope, then everything is going to run in a transaction. So that makes it a lot easier to compose transactions efficiently. All right, more cool Drift features. We have a DevTools extension. So I hope you've used DevTools before. I think they're quite convenient. And you just get a link to them whenever you debug a Flutter app. And then if you've used Drift anywhere in your dependencies and you open DevTools, like I'm really bad at taking screenshots apparently, but there's going to be a tab here that says Drift. And if you click on it, you will get to this kind of screen. And we show you all databases that have been opened using Drift. And if you select one of them, we will show all the contents of your Drift database in a way that makes them very easy to explore. And another cool thing is if you select like a table or a row to inspect, and then if you update through whatever means that database in your app using regular Dart code, it's going to immediately get updated and reflected in the DevTools extension. And similarly, you can update stuff in the DevTools extension, and that will immediately update query streams operating on that data in your app. So this is like a really convenient way to inspect databases regardless of what device you're on. So these DevTools extensions, they work on all platforms where Drift runs on, which is all the Flutter platforms. All right. Like a final kind of feature shout out I want to give, or not shout out, I mean, I did all of the work, but yeah, so there's running SQLite on native platforms and running SQLite on web platforms is a pretty different thing, because on native platforms, say C library that you can just invoke synchronously using .ffi. But on web platforms, it's kind of challenging because some web APIs that we want to use are only available for dedicated web workers. And obviously your Flutter app, like your main UI, is not running in a worker. So what we kind of have to do is we pretend that we can call SQLite directly, but what we're actually doing is we're sending messages through a dedicated worker that the library manages for you. That will then run the queries, send the results back, and we just pretend that everything happens in the same context. So there's a lot of cool technology happening underneath there. And this is also, I would say a pretty nice feature about Drift is that Drift APIs on the web and Drift APIs on native platforms are exactly the same, right? Like you don't have to use conditional imports or anything like that. You just, use it the way you would use any other Dart library, and you can expect it to work across all platforms. Internally, there's quite a bit of magic we have to make happen for that. So you have to download the SQLite library as a precompiled WebAssembly file. You have to download the actual worker that will, try to make SQLite functionality available to you. But then once you give Drift those URIs, there's like a single function that gives you a reasonable default configuration for Drift across all platforms. So those are the kind of features that I wanted to talk about in Drift. I will talk about some advanced things towards the end of this talk. But first of all, like a question that I get quite a lot is, okay, I have adopted Drift now, but how do I actually use it in a non-trivial app, right? And I know that apparently people are tired of state management talks. So my takeaway is I don't care. Like use literally any state management solution you like, because if you have a state management solution in your Dart app, it's probably going to be reactive, which means that you can plug streams into that. So Drift works by providing you with a stream of updates or a stream of query results. And then how you display those is like not my problem, right? Like you can use stream builders in Flutter or whatever the Jasper equivalent is if you're using Jasper. You can introduce a domain layer in the middle of it, right? Like you can use async notifiers from Riverpod. You can use stream providers if you're using the provider package. You can probably use getX or whatever, right? Like everything that takes a stream, you can use with Drift. And the kind of key takeaway I would recommend is put the database like front and center of all your state management leads, which means that if you want to show something that is derived from app state, it should be derived from a database query, and then the actual state should live in the database. Because what that enables is all your widgets, either they write directly to the database or they go through an immediate layer that writes to the database. And then every write to the database is going to get reflected with some stream updating. And that is just kind of very convenient because all your widgets that depend on state one way or another, they're going to get updated for every write. And you kind of don't have to do that manually. So if you're, I don't know, using shared preferences or something like that to store local data, then you would probably have to use a custom stream controller somewhere internally to ensure that the kind of things that depend on your local data, they get updated as the local data is actually written. And with Drift, you kind of get that for free, regardless of how complex the data flow is in your app. So yeah, using the database as a sort of truth is kind of what I would recommend. Okay, so now I just want to briefly go through two kind of cool advanced features with Drift, just to give you like a taste of what's possible when you're using a database toolkit like Drift with SQLite. So the first thing is, I mentioned that SQLite has a static schema, and I think that that's generally a pretty good thing, right? Like we define all of our columns and their types ahead of time, and then SQLite is going to enforce them when we do a write to the database. And if we get this wrong, then we get a runtime exception. And one thing we don't get is a corrupted database, right? So I think that's generally a pretty good thing. But sometimes we might have to change them, right? Like as our app develops, we might have to introduce a new table, a new column. Maybe we have to delete tables eventually or change column types. And in SQLite and all other relational databases, this requires some special migration, right? Like we need to tell the database, hey, I previously told you about this table and these columns. that's no longer true. You should now use a different table format. So to do that in Drift, we just update the kind of root table definition. So if I was using a Drift file, I would just add a new column to the create table statement. And if I was defining my tables in Dart, then I would just add another getter to represent the new column being added. And then I bump the schema version getter that is part of the generate that I should have as part of the app database class that I write with Drift. And then there's this magic command called make migrations. So if you're using Drift, you will already depend on DriftDev because that's also the package providing the builders for the build runner system. And so in your Flutter project, you can just run dart run DriftDev make migrations. And if you do that before and after making the migration changes, then what Drift will do is it exports a full copy of your database schema as a JSON file that is going to be valid as long as the Drift project exists. So we will never have some backwards incompatibility with that. You can just keep that and commit it to your repository. And if you then update the schema and rerun this command, we will see, okay, there's been a schema change here, which means that we will need a migration. And Drift will help you with those migrations. So there's some APIs for that. But something that Drift will also do is it can automatically verify the integrity of your migrations. Because these JSON schema files, they store a copy of all the schemas you ever had in your app. So what we can do is we can start at an old version of your schema, like the initial users tables that didn't have the email column. Then we invoke your migrations. And then we extract a dump of the current schema after your migrations, and we assert that they match what I would actually expect, right? And this is then a really powerful feature because you basically you can't get your migrations wrong, right? Like this is a pretty common issue if you're working with relational databases is, okay, I got the migration wrong and now I have some annoying data loss issues. And with Drift, you can write unit tests for your migrations. And in fact, most of this unit test writing is completely automatable. So, in this case, if you add a new column, as I shown before, we are adding the emails column, and this is a nice one-liner in Drift. So I override this method defining how migrations work in the database. And then the step-by-step function would be generated by Drift because I've told it about the schema version before and the schema version afterwards. And I just get the expected schema at that variant. And in this case, again, you can read the docs, obviously, if you want to have like a full overview of everything that is possible with migrations. But for instance, adding columns is a very easy thing to do. It's just like a single one-line command that you can run. And then, again, because Drift generated the migration test helpers, all of this is going to get unit tested as soon as you run Flutter tests. Speaking of tests, like the one final Drift feature I want to show you, I've kind of gotten this a lot as questions in the earlier phases of the project because initially we didn't have Dart FFI available to us and we could only use platform channels to invoke SQLite. And then it's pretty complicated because if you want to test a database, we obviously in Flutter unit tests, we don't have platform channels, right? Like we can use platform channels in integration tests, but integration tests are like super expensive to set up. They're annoying to debug. They're kind of flaky intrinsically if something in the test runner breaks. But widget tests or unit tests in general in Dart are really, I would say, very convenient to write. And so the question then is, how do we write unit tests relying on Drift databases? And my like single biggest point is please don't mock your Drift database or your SQLite database in general, because what you can do with SQLite, typically the usual advice is SQLite, since it's a file-based database, and you kind of don't want to store temporary files in tests, it kind of gets annoying. But what you can do in SQLite is you can declare that instead of storing a database file on disk, you can just say, okay, pretend that you are storing it on disk, but actually have like a virtual in-memory file system. And it's really cheap to set this up. So you can just use your regular setup and teardown blocks in your Dart test file, and then you can give each test an individual SQLite database. And then as a test is coming to an end, you can just close the database. And because it's in memory, this is like super cheap to do. And you can easily have tens of thousands of tests all using an individual database from scratch without that meaningfully affect your test time. So this is also the same way that Drift itself is tested, and it's a pretty reliable way. And compared to using mocks, I think the main benefit is that you just have a wider test coverage, right? Like, let's say you had some repository layer in your app, and then typically you would say, okay, I have one implementation based on the Drift database, and then I have another implementation just based on like some in-memory mock. and then you can test the rest of your app. Like you can test your domain layer and you can test your UI with that. But you would never actually test your Drift database in that setup, right? And this just gives you that for free. So I would, generally recommend, avoid mocks for databases as much as possible. So another cool way you can do that is, this is kind of like a pretty advanced topic, but something that comes up quite a bit is, okay, but let's say I want to mock the current time, right? Like this is just a thing that you sometimes have to do where, okay, I don't know, I have a column in my to-do list tables, and then when I add a new to-do list item that stores the current date and time. And then in tests, obviously, I want to assert that that is working as intended. So I just write a test inserting and then just reading the item back. And then it's kind of hard to write assertions for that because the output of the select depends on the time the test was run, right? So typically, in Dart, we have the fake async package or the clock package, which we can use to make this deterministic in Dart itself, right? Like in Dart, you can reliably mock the time if you avoid using datetime.now and instead use the clock package. And most of the Flutter framework is doing that already. But SQLite, because it's a C library, it doesn't care about your Dart mocks by default, right? Like it literally doesn't know about them. But something you can do in SQLite is you can use the SQLite test package, which I also wrote. And then you can register a custom file system called test SQLite file system. In this case, I'm just kind of giving it a random name because tests could run concurrently. And in a single SQLite instance, you shouldn't have naming collisions there. But it doesn't matter too much. The important thing is you register it and unregister it for the entire test file. And then as you open an in-memory database, you pass the name of this test thing. And then if in any point of your test you attach, if you use like a mocked time, then everything that SQLite does will also reflect that mock time. So you can use the current timestamp command in SQL, and the output of that is going to be the value that you've mocked in Dart. And again, here I'm using a local file system in Dart, so all of the I/O would also go to the Dart file system. And yeah, if I wanted to, really pretend that I'm using a SQLite database that is written to disk, but actually use, I don't know, some custom test file system for that, I could do exactly that using this package. So for like really advanced test setups, I would recommend using the SQLite test package. All right, now we are coming to the end of my talk. And sort of as a final outlook slide, I would like to kind of show you what has been happening with Drift. So at this point, I think I started it in some February, so probably 2019. Yeah, so it must have been like 7+ years at this point. So Drift has been around for a while, and I think at this point, Drift is a pretty mature and stable library. Like the current version is 2.32, so we have had 32 subsequent releases without really breaking anything. And I hope that this reflects that, yeah, Drift is a mature, stable library. And if you're using SQLite in your app, then I think Drift could be a really interesting choice for you. In terms of things that are happening right now, because we already support most of what SQLite supports through Drift files and have a pretty complete Dart API, there isn't really that much more to add. So mostly at this point, I'm just looking at ecosystem improvements and make sure that we can use those as effectively as possible in Drift. So for instance, browsers are getting better with supporting WebAssembly all the time. And there are like new web APIs we can use for SQLite. And obviously, it's kind of my job to make sure that Drift is able to exploit these web APIs as good as possible. Another thing that we kind of didn't get because we didn't get macros in Dart, but there's this feature called augmentations that makes it easy to, or possible even, to specify a single Dart class or a single Dart method across different files, and then some of these files can be generated. And that will make it a lot easier, or will enable some kind of way to declare databases that's going to be a lot easier than what we had before. So I'm excited for that. I also want to look at better backend support. So Drift itself supports SQLite mainly. We also have some limited Postgres and MariaDB support. And I would like it to get a lot better at that, so that you can essentially use the same Drift database code in your front end, like in your Flutter app. And then if you have a Dart backend, you could ideally use the same code. The final thing, adopting build hooks, it's kind of a technical detail. Previously, it was quite hard to bundle SQLite along with your Flutter app, and with the Flutter release, I think it was 3.38 from like last November, it has gotten a lot better. It took me a while to adopt that in Drift, but I did that this weekend. So, the last item is kind of has a check mark behind it. So yeah, Drift is even easier to use across all platforms now. And yeah, that's my talk. Thank you.
Wow, that was impressive. Questions, raise your hands. Michael, you will be second.
Oh, thank you for the talk. You told that Drift or the SQLite to use or to implement for the web is a bit harder. And I'm wondering what's the current state of Drift regarding the web and especially regarding the WASM.
Yeah, so with WASM, do you mean like Flutter apps compiled to Data WASM specifically, or just general web situation?
No, Flutter web compiled to WASM.
Yeah. So because in Drift we use a worker for accessing SQLite, it doesn't really make much of a difference if your client code is compiled using Data.js or Data WASM, because SQLite itself is typically accessed through that worker, and we compile that worker to JavaScript currently. So using Drift with Data WASM app on the web should just work.
Okay, thank you.
So first of all, thank you very much for your great work on the Drift. It's like, I believe it's the best solution for databases, and I expressed it in Kitchen as well. So I have two questions, and I actually written down. So the first one is, what do you actually recommend when for creating tables? Do you use only SQL schema definition, or Dart definition too? Because currently I use only SQL, and I don't really like it. But I feel that I have a feeling that Dart definition may be too limited or something.
Yeah, so for tables, pretty much everything that you can possibly express in SQLite, you can express using Drift's Dart definition syntax. The same mostly goes for indexes that you define on your tables and also views. For triggers itself, you would probably have to keep using SQLite, so like create trigger statements. But like a cool thing is that you can mix and match those, right? Like you can import Dart definitions into Drift files, and obviously you can reference Drift. Well, actually that's not possible, but like the other way around is a bit trickier, but generally also works with some exceptions. So I would probably say use a consistent approach within a project just to, make your life easier for you and your coworkers. But, apart from that, maybe I would mostly say it's personal preference, right? Like if you enjoy writing SQL, then by all means go ahead and write those create table statements. If you say I would rather use a Dart solution, then you can use these Dart definitions. And especially with augmentations, I think the Dart definitions are going to get a bit easier to define in the future. Like at the moment, you kind of write the table as if it were a create table statement, right? Like there's this extends table, and then all the columns just look kind of weird. That's going to get a lot better. But yeah, like again, it's your choice, I would say.
Thank you. And I have the second question about watch methods.
Yeah.
So is it generally a good idea to have like this, to use these watch methods? Because what about the performance of them?
Yeah, so I would say in general, you should use watch methods as the default. And then if it turns out that they are like, for a specific use case that you have, they don't perform as well as you'd like, then that's something worth investigating. So, I mean, first of all, I think in general, the expectation you should have is that Drift should be fast enough to support most reasonable queries using the default APIs out of the box. And like just in the latest release, I did fix some actual issues there and make it a bit faster for some common use cases. And I also think that this last step of adopting build hooks, like I don't want to go like all into it, but that's going to enable some really cool patterns to make Drift a lot more performant, or SQLite in general a lot more performant on Dart. So yeah, I think like the baseline that you can get with like just using watch methods is going to be like pretty good. Like obviously, if you have a table that selects, I don't know, hundreds of thousands of rows, and it's a table that gets written to all of the time, then maybe you shouldn't have a stream rerunning and selecting a full 100K rows every time that it gets written to. Well, like at that point, you should probably look into pagination or something like that. But yeah, like that's a point where I would say, okay, we have to think about some custom solutions. But yeah, I think, if you have been having performance issues, then, I would appreciate like feedback because that's something I should fix in Drift.
Thank you.
Okay. Well, I get up, so maybe I will stay. You will see me. First of all, thank you for coming. It's really nice to see the face of the author, that solution I could use, yeah, and solve my problems in project in just a seconds. According to the project, we had a case. We had to store complex data, yeah, as a database object, but it was all text-based. But along of that, along with the article, we had to store also the audio file, yeah. So this is question about the media. And of course, we just stored in the database after the save the path to the file. Yeah, that was quite cumbersome, yeah, but straightforward solution to that. Do you know maybe some better ways to correlate medias or store medias in the SQLite, or maybe especially in the Drift?
Yeah, so I don't have like first-hand experience with that, but what I have heard is that SQLite is quite good at storing also non-trivial binary data in just like, you have like different column types that you can use in SQLite, and blobs or like binary data is one of those. And from what I've heard, that works quite well into like maybe like the low digit gigabyte range. So if you know, let's say you're not exceeding, I don't know, let's say 2 gigabytes in your individual media files, then just storing them inline in the database is actually not that terrible of a choice, right? So for images, for instance, I would just say, you know, that can be quite reasonable. Maybe for like large, I don't know, 4K videos, it might make sense to use something different. But in general, yeah, so storing media exactly inside the database can also be quite convenient. Because yeah, SQLite can sort of seek into that and extract like a subset of the blob efficiently if you want to use something like that. So that can be perhaps an approach where you don't have this external path that you have to embed in your database.
Yeah, okay. It sounds that blobs really could do the job. So
yeah,
thank you, Reo.
Okay, another one.
Hello, thank you for the talk. It was awesome and really nice to see you in person. So let's say tomorrow you join a company. They're using, unfortunately, Hive. They have like 50 or 60 different files with Hive. How would you go about migration to your better Drift?
Yeah, I mean, assuming that was actually a project, right? Like I always say, you know, obviously, you know, having written Drift, I'm a fan of SQLite. That's why I wrote Drift. But like, I don't want to, you know, sort of single out any other solution and call it bad explicitly, right? Like,
of course.
I mean, I'm sure you won't do that either, right? Like, just to get that across. Yeah, I think because it uses the type safety, and typically in like large projects, you would also have some type safety around Hive using some code generation. If you're, I don't know, using JSON serializable or, you know, whatever they have built in for Hive, then you can probably get similar structures using Drift. And, you know, something that is quite challenging is obviously you can't have a transaction that spans across Hive and SQLite databases because they're different systems. But just for the actual queries, you can probably just port different collections to SQLite one by one. It's a bit tricky because with SQLite you have the static schema, and in Hive you technically don't. So I would say it's probably a massive undertaking. But I think in general, doing it like table by table or in Hive like box by box or whatever should probably be possible.
Thank you.
Okay, last one.
Hi, thank you for your talk. I wanted to ask if it will be even possible with Vue in Dart files to define custom names for fields, because I had an example that I had to define Vue, and I could change name, but then field will be new label, and I wanted to make it not the same as in original table. So I had to use Drift files, not Dart file.
So I think if you, we should probably talk in person at some point, but I think you can, for these Vue definitions in Dart files, you can add like an individual getter for a column you're trying to select from. And then you could just have that column with the custom name that you want to use in Dart. And then the definition of that is going to be the underlying column from the table with a different name. And I would expect that should mostly just work. So maybe we can go through some examples.
But this way will make the field new label. So, for example, when we have string and non-nullable, then with way of getter, we will have nullable field.
I see. Maybe I should look into some Drift APIs
Okay.
to make it easy. We should
Thanks.
definitely talk about
Okay.
that.
Okay, and any last question from the audience? 3, 2, 1. Thank you, Simon. Thank you for your talk.